Hi, I am Darshan. I will be explaining about the Kruskal's algorithm in the concepts of analysis and design of algorithm. At first, Kruskal's algorithm. It is an greedy algorithm used to find the MST, which is an minimum spanning tree of an connected undirected graph. Then we need to know what is an MST. It is an minimum spanning tree is a subset of edges in an connected weighted graph that connects all the vertices with a minimum total edge with weight and without forming any cycles. It ensures that the most efficient way to connect all the nodes in a network or a system. Now working of Kruskal's algorithm. It sorts all the edges by weight in a non-decreasing order and then initializing the minimum spanning tree, which starts with an empty set T for minimum spanning tree edges, then iterates and adds the edges if it does not create any cycle, and stop the condition when T contains V minus 1 edges. In short, it it works by sorting all the edges of the graph in a non-decreasing order of their weights. Then it adds the edges to the MST by one, ensuring that no cycles are formed. Using a disjoint set data structure, the process continues until the MST contains exactly V minus 1 edges, where V is the number of vertices. Then we'll be going through an example. Here they're given a normal graph. At first we need to sort the edges by in the increasing order. At first, here is the increasing order, sorted increasing order of the edges. Then we will be creating the MST. At first A to E, which is 10, and we will be implementing here. Then B to D, F to C, B to F, and E to F till E to F we will be considering here. Then A to B is 60. It is not considered because if we join A to B, a cycle is formed here, which is not considered as an MST, minimum spanning tree. Then even B to F is 70. If we join B to F, then again the cycle will be formed in this part, again which is not considered as an MST. At final F to D, which is 80, even this is not considered here. Finally the sum will be 150, which is the final minimum spanning tree. Now, advantages and disadvantages of Kruskal's algorithm includes: at first, efficient for sparse graphs. Performs well when the number of edges is much less than the number of vertices, and simple and easy to implement based on sorting and union fixed, making it conceptually clear. Always finds the optimal solution. It guarantees a minimum spanning tree if graph is connected. Disadvantages of Kruskal's algorithm includes: requires sorting. Sorting edges can be time consuming for large graphs. Disconnected graph issue doesn't work properly if a graph is not created. And union find overhead needs additional data structures which are disjoint sets, which can be complex to implement efficiently. And here is the time complexity of the Kruskal's algorithm. At first, sorting the edges, which will be O E log E. Then cycle detection, overall complexity, and if the edge is sorted, then the time complexity is given. And applications of Kruskal's algorithm includes network design. It is used to design cost-effective computer, electrical or road networks by minimizing the total connection cost. And clustering in machine learning helps in forming clusters by removing the most significant edges in the hierarchical clustering. Approximation algorithm used in solving the problems like traveling salesman problem using minimum spanning tree based approximation methods. And finally the summary. Kruskal's algorithm is a greedy technique used to find the minimum spanning tree of an connected weighted graph. It begins by sorting all the edges in increasing order of their weights. Then it adds edges to the minimum spanning tree at one at a time, ensuring that no cycles are formed using an union find data structure. This continues until all vertices are connected. Kruskal's algorithm is an efficient for sparse graphs and guarantees the lowest total cost of connecting all the nodes in a network. Thank you.